Hi folks, and welcome to part 3 of this series. We're implementing a library and utility that can encode hidden messages into PNG files, and of course also decode them later. If you haven't watched the previous 2 parts, please do so before continuing with this. In part 1, we handled chunk types, and in part 2, we handled chunks. Now we have to implement the PNG type in our crate. And let me show you what that involves. Let's go back to the drawing I made for the previous video. So this would be the structure of a PNG file. And previously we handled the chunk type that's in a chunk and the whole chunk. And now we need to implement this type, which is essentially not that hard. We only have the header and a list of chunks. The problem will be when constructing this file structure from plain bytes, because we don't know the exact length of this. So we will have to read the length first to determine how much we need to read further, and then read accordingly to the length, and then do so repeatedly for the next chunks in the list. Alright, let's go back to the instructions. As always, we'll begin with copying the unit tests. Let me go back to the IDE. And it wrapped it in a main file, in a main function, which I will delete. As you can see at the end of this test, we have a PNG file defined as raw bytes. Let me go back to the top. And I can remove this. Okay, let's go back to the instructions. Okay, we have to write the PNG struct. Okay, we have to store the header bytes in a standard header. Try from. And we need these methods. Okay. Let's define the PNG type first. We'll just leave it like this for now. Oh no, let me define an impl block. Impl PNG. We're gonna paste the methods here. I think we can import chunk. That's good. Okay. And we also need to implement try from and display. Implement try from slice of bytes for PNG. Of course, let's just use the blanket implementation for now. Also implement display for PNG. Let's import display, generate the blanket implementation. All right. Let's go back to the instructions. Oh yeah, it recommends storing the header in the impl block. Okay. All right. Let's try starting with the standard header. I'm gonna go back to the PNG specs, which I haven't opened. Let me open them now. Okay, and this is the standard header. Let me just copy it. And let's put it in the impl block. Okay. Standard header, which would be an array of 8 bytes. and it would be equal to this. Okay, that should be fine. Let's go up and define the structure. And since we have the header constant in the impl block, all that we need to do is store the list of chunks in the PNG. So we can define chunks, and this would be a vec of chunks. And that should be about it. Okay, let's handle these methods. For now, it should just be a PNG with chunks, just a vec for now. Okay, this is gonna compile. All right. I think we need to import the type alias for the result again. And I think we can update try from here. Okay, that should be good. And this, let's return an okay. I think we just return, let's just return an error for now actually. The error from the crate for now. Here I think we can just return the header from the impl block to just be self. Oh no. Like this. Oh, it needs a reference to it. Okay, that's good. A reference to a chunk. Okay, we can't. For now, I'm gonna leave this empty. Let's just return none here. And this for now. Oh, okay, we still have errors. So we need some methods in chunk to be public, new as bytes. Anything else? Chunk type, data as string. Okay, let's handle this right now. So new, this should be public. Chunk type as well. Data as string as well as bytes. Now let's go back and see how many errors we fixed. Okay. Looking good. I think it's just this return type here. Okay, looking nice. Actually, we can implement the last method that has an error as well, because this should be self.chunks as slice. Okay, looking good. Let's check. In the try from, we're still returning nothing. So we need to implement this. And this is gonna be the largest part of the video, I think. All right. Let's just define the error first. It should be, again, the error in the crate. Okay. Let's say an empty chunk vector. This is gonna be the result we'll be returning. And let's define an iterator over the values here. Okay, chunks iter. Or I can actually just, I think I can just call iter. I don't need into iter. All right now. So now we should just get the first 8 bytes and check if they match the header. Okay, can I write this in one go? No, let's just collect them. Okay, header bytes equals chunks iter dot copied, or do I need it? Let's just use byref to make sure we're modifying it. Let's take 8 bytes. And this. And I think we can just use a vec. Let's just copy these and collect. All right, this is fine. Now let's check if PNG standard header is different from header bytes. And I think here I think standard header, I need to turn this into a slice for them to be compatible. And let's just return an error. Okay. And the message should be invalid header bytes. Else I think, let's just do an early return here and continue with the logic. Okay, so we're checking the header, and now we need to start reading the chunks, and this needs to be done in a loop. And let me go back to the drawing. So here the minimum length of a chunk should be 12 bytes because these 3 are 4 each and the data can be 0. So the minimum for a valid chunk should be 12. So let's try to take from the iterator while we still have 12 left. So let's say while chunks iter dot len greater or equals 12, and in this case, yeah, we can start checking the length. So we need to check the first 4 bytes. Okay, let's say let first 4 equals, And we're going to need to take bytes from the iterator without modifying it. So in this case, we will not be using the byref adapter, but we'll be consuming the iterator. So in order to still keep a reference to this, we will need to clone it. Let's say chunks iter dot clone dot take 4. Oh yeah, let's just define the type straight away. An array of 4 bytes. Take 4 and collect in a vec view 8. Oh, I forgot. Okay. As slice and try into. That should be fine. Okay, so now we have the first 4. Now let's create a length from it. U32 from big endian bytes. First 4. It doesn't like. Oh, I think. Yeah, we have to unwrap here. No, I still think it just doesn't like that we're not returning anything. Let me... Yeah, I'm just returning an empty PNG at the end, so we're not bothered by the errors here. Okay, so essentially this worked. Now we know the length, and now we need to read from the main iterator the number of length. So let's say let chunk bytes equals chunks iter byref. So this will modify the iterator. This doesn't modify it. This just clones and consumes the clone. Okay, byref take, and we're going to take the length as usize and we're going to collect. Let's just define the type again. This is just a vec of u8 and okay, collect into a vec view 8 as slice and try into. Again, we have to unwrap and change the error. And now we can use try from for the chunk on the chunk bytes. So let's say let chunk equals chunk and try from and a reference to chunk bytes. Okay, let's unwrap this here as well. So we have the actual chunk type. And now, how did we call it? I think just chunks. That's the result container in this method. I'm just gonna push this chunk here. And we're doing this inside the while loop. Now I think I can just... So I deleted the colon, so this will match with the shorthand, the chunks from here. Okay, I think this should be it. All right. Let's check this. So at line 30, I think it's just better. I can remove these, I think. I don't need to do all these transformations. I can collect into a vec, and I can just remove the turbo fish from here. A vec of U8. And this can just be chunk bytes as slice. And this should be good, I think. Let's try again. So, we just have an iterator item. So we have an iterator. I think we just forgot to use the copied adapter. Let me try here. Copied. And we would need to do the same here as well. Copied. Now let's try again. Okay. 19 and 12. Oh, I need to use a return here since this is not the last statement. Okay. So this works. It compiles. I'm gonna do a format. Okay. So we have a few failing tests. Let me try running them in the visual mode. And see which of them fail. Append chunk as bytes. So only 2 of these. Okay, let's start checking them. Actually, let's just look at the methods in the impl block because we haven't implemented those. A lot of them are just placeholders. Okay, let's start with the first one. For from chunks, we're returning an empty vec right now. We're just going to change that with the shorthand notation and just set the argument from here in the struct. For append chunk, chunks is already a vec, so we can do self.chunks.push chunk. This should be enough. For remove chunk, let's get the position. So let position. Oh, there's a slight typo. Self.chunks. Let's get an iterator. And we can use the position adapter which takes a closure over the chunk, and we have a predicate that checks the condition we want, which should be c.chunkType. Let's convert that to a string and compare with the chunk type we have as an argument. And now we're getting an option for the position, a new size. And now let's use if let. So if let sum, I think I can use position again, though it's kind of weird, equals position. Can I redeclare it? I think that should be good. I'm shadowing position here. In this case, we should just remove and return an OK variant. And the remove actually returns the chunk. So let's say OK of self.chunks.remove position. OK, else we can just move this up and that should be good. Let's see next. The header is good. We haven't implemented the chunk type. So let's do self chunks. We're going to iterate over this. And let's do find. And we have to give it a closure. Let's say where the chunk type for the chunk. Let's convert this to a string equals the chunk type provided as argument. That should be good. As bytes. Here we need to concatenate the header bytes with the bytes in the chunks. So let's see. Let's define a results vec. And let's extend the result. Again, this will add the collection to this one with the header bytes, which should be self.header. That should be good. Okay. Oh, of course. Let's make it mutable. Okay. And now let's loop through all the chunks. Okay, let's say, yeah, just in self.chunks. And let's just do result.extend chunk as bytes. And let's just return the result. I think that should be good. All right. We've covered all the impl methods, but I think we haven't covered display. Yes, this is still a to-do. Again, the write macro, give it a formatter. We're going to be using the debug notation. And I think it should just be self as bytes. I think this should be good. Okay, let's just test this with what we've implemented so far. We have an error here. Okay, we're having a move here. I think we can just use a reference, and this should be good. Let's try to test again. Okay. We still have 4 failing tests. Let's see. As bytes. Okay. We have an error variant when trying to unwrap at this line. So we know the PNG input is valid. So this should be an okay variant, but we're getting an error. Let's go inside the implementation and check. Okay, we're checking the header bytes. This might return an error variant. But these should be okay because the header is valid. The whole file should be valid. Let's look to where we're having error chaining. So we have here when we're getting the first 4 bytes. But this looks all right. And here. So this is probably the one that's failing. It means that this try from doesn't work. But this should work because it's implemented on a chunk type, which was tested during the last part. And that means there's something wrong with the bytes. So the collection doesn't have the structure of a chunk. I think it's this. Let's see. So the issue here would be that we're trying to take a length of the chunk, but the length that we calculated is just the length of the data field in the chunk. Let me go to the chunk and show you. So we have all these inside the chunk. And yeah, the length just points to the length of this. And we need to add all of them. So all the other metadata is 4 bytes. And being 3 of them, yeah, we need to take 12 more. Going back to the code. Okay. Did I go back to the proper place? Oh, it's here. Yeah, I've added 12 more bytes here. And I think this should fix it. Okay. Great. So all the tests are passing. All right then. That's it for today. Let me go back to the assignment for a quick recap. So we've handled the first 3 chapters, the chunk types, the chunks, and the PNG representation. Next time, we'll be handling the command line arguments. Let me know what you think, suggestions, questions in the comments, whatever you'd like, and see you next time.